On this RAM 1500 with the 3.6 Pentastar, P0032 points us toward the O2 sensor 1/1 heater circuit reading high. In plain terms, the PCM may be seeing too much resistance or the wrong electrical behavior in the upstream oxygen sensor heater control side. The MIL may be on, and depending on what the heater circuit is doing, the PCM can disable heater control for that ignition cycle. Broadly, think possible heater control circuit faults, ground problems, connector issues, the sensor itself, or after the rest of the circuit checks out, the PCM. If other codes are present, check what they mean first, but keep this diagnostic focused on P0032. Before testing, it helps to understand what the PCM is watching. Normal range of the O2 sensor output is a 0 to 1, 0-volt analog to digital signal, and a negative offset output of up to -1. 0-volt may be introduced. Each O2 sensor return circuit has a 2-5-volt bias, so the bias signal voltage should switch between 2, 5, and 3, 5 volts on a normally functioning sensor. When the heater side has a problem, the bias signal voltage can read high and usually stays above 4.0 volts. A small amount of resistance, 3-4 ohms, may not set a heater control circuit DTC, but it can still skew what you see. A heater circuit with 4.05 ohms resistance can increase the heater temperature reading on the scan tool for the affected sensor by as much as 700 degrees F, and as little as 2.0 ohms can increase the temperature reading approximately 250 degrees F on the scan tool. When a switching O2 sensor is heated and operating normally, the typical duty cycle percentage will range between approximately 30 and 50%. And the typical heater temperature will range between approximately 1,200 degrees F and 1,400 degrees F on the scan tool. If the PCM disables the heater driver, the duty cycle will be 0%. There are a couple of signal patterns worth keeping in mind while you diagnose the heater circuit. If the O2 sensor signal is shorted to ground cold, the bias signal voltage can be at 0 volts, while the 0-1 raw voltage signal will read -2.5 volts and increase towards 0 volts as the sensor heats up. Once warm, both can read near 0 volts. An open in a sensor return circuit will cause the biased signal voltage to read high, near 5.0 volts, and the 0-1 raw voltage reading to be near 2.5 volts. Those values do not replace the circuit checks, but they can help you recognize whether the scan data matches the electrical direction you are testing. For this code, the key idea is heater circuit resistance. The monitor runs with battery voltage between 10, 5, and 15, 75 volts, and P0032 sets when the PCM detects O2 sensor 1/1 heater circuit resistance above approximately 35.0 ohms. Before getting into circuit testing, start with the basic system checks and check for any applicable service bulletins or PCM software updates related to this DTC. If one applies, perform that repair path, then verify the repair and confirm the code stays gone. If nothing applies, continue with the diagnostic path. Next, use the scan tool to read codes in all modules and record them. Save the scan report or the environmental data tied to the fault, then erase the codes. Turn the ignition off for a minimum of 10.0 seconds, turn it back on, and operate the vehicle under the captured conditions and the monitor gates that set the fault. Read codes again. If P0032 comes back, move into circuit testing. If it does not return, treat it as an intermittent condition and avoid replacing parts based only on the stored history. Now isolate the ground circuit by disconnecting the component harness connector, then load test the Z933 ground circuit. Connect the positive lead of the load test tool to battery positive and the negative lead to the ground circuit at the component connector. The bulb should be bright, and you compare that brightness against a direct battery connection. This matters because a weak circuit can look okay with a meter and still fail under load. A 3156 bulb has approximately 6 0 ohms of resistance when powered and draws approximately 2.0 amps. A 12-volt test light can be used only if it loads the circuit enough. Many high-impedance test lights draw less than 0.1 amps, and the tool should draw more than approximately 0.75 amps for a proper load test. As an example, 2.0 ohms of resistance in the circuit being tested will cause the voltage measurement across the bulb to be 25% less than when compared to battery voltage, because the 2.0 ohms in the circuit makes up 25% of the total circuit resistance of 8.0 ohms. Do not probe PCM harness connector terminals directly. Use the GPEC diagnostic adapter when a PCM connector terminal has to be accessed. If the bulb is bright, continue. If it is not, repair the ground circuit for an open or high resistance, then verify the repair. With the ground circuit passing the load test, move to the O2 sensor 1/1K99 heater control circuit. The ignition must be off for resistance checks. Isolate the circuit by disconnecting the control module and every component connector that contains that circuit, while leaving the inline connectors connected at this point. At the PCM harness side, connect the DVOM to the K99 heater control circuit, then probe the other circuits at that connector. With the circuit isolated, there should be no continuity between the circuit being tested and any other circuit. Again, use the GPEC diagnostic adapter instead of probing PCM terminals directly. If continuity is found to another circuit, repair the short between those circuits, using the circuit path and inline connectors to narrow down the location, then verify the repair. If there is no continuity, keep going. Next, check the K99 heater control circuit for an open or high resistance. Keep the ignition off. Isolate the circuit by disconnecting the control module and the component connector, and check the meter lead resistance before measuring the circuit because the leads can add resistance to the reading. Measure the circuit from the component connector to the GPEC adapter. Remember, the GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. The decision point here is whether the circuit resistance is below 3.0 ohms. If it is below 3.0 ohms, continue. If it is not, repair the circuit for an open or high resistance, then verify the repair. If the ground and heater control circuit checks pass, check whether the PCM heater control driver can operate the circuit properly. Turn the ignition off, reconnect the PCM C2 connector, then turn the ignition on. Use a 12-volt test light connected to ground and probe the O2 sensor 1/1K99 heater control circuit at the O2 sensor 1/1 harness connector. With the scan tool, command the O2 sensor 1/1 control to the maximum allowable percentage. The test light should illuminate, and brightness will depend on the commanded percentage. Then command the control OFF at 0%. The test light should go out. If the driver responds correctly both ways, the diagnostic path calls for replacing O2 sensor 1/1, then verifying the repair. If the test light does not respond correctly, continue to the connection checks. At this point, inspect the related PCM inline and component connections. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Look closely for poor connector installation, damaged locks, corrosion, signs of water intrusion, whether seal damage, bent terminals, overheating from a poor connection, terminals pushed back in the cavity, spread terminals, and poor terminal tension. Repair any condition you find. Then reconnect the PCM connectors, inline connectors if equipped, and component connectors, making sure everything is fully seated and locked. Erase the codes, operate the vehicle under the conditions that set the fault, and read codes again. If P0032 returns after these checks, the diagnostic path calls for replacing and programming the PCM, then verifying the repair. If it does not return, the wiring or poor connection problem has been repaired. Keep the verification step separate from the circuit testing. After any repair, clear the codes, reproduce the operating conditions, and confirm P0032 stays gone. The clean way through this one is: confirm the fault is active, load test the ground, isolate the heater control circuit for shorts and resistance, Command the driver, then inspect connections before condemning a module. For more diagnostic training, visit Step Diagnostics. Com.